Okay, so I'm actually going to flip to the example here just to sort of explain the thinking behind some of the stuff it does here. So I've introduced this idea of levels mapping to numbers because this is important for the next stage of the task, which is only logging at a certain level and above. So you kind of need the numbers there to be able to compare against. There's a whole heap of stuff in here as well, which is using some of the bits and bobs from Crocs. So you can set the level for logging output as a process, as an environment variable, using process.env.nodeEnd. Oh, sorry, log level, not that one. And then that's used in a logger that I've written here to just check if the level that the thing is being logged at is acceptable to be used and actually output something. So this looks quite a lot more complicated than the other version here. It doesn't necessarily need to be, but I found that this was just sort of the minimum amount of stuff that I wanted to have that would be kind of production worthy. Essentially there's a couple of different elements to it. One is this log here that will take a level, a tag and a value. So you can build a logger that's going to have lots of information around the context of its use. So the level will be telling you like the severity, obviously. The tag means you can build a version of this logger per module or per use case. So everything that's related to the same sort of thing will be tagged in the same way. So I might have something specifically for an API call and it'll be tagged API. And then the values. Just up here, a little bit to parse out the values so I can get a body that's going to make some sense. So if I just pass in a string, I'm going to want it to say message is this, and if it's a number, I'm going to say value is this. If it doesn't match number, string, or object, I'm just going to silently ignore it. And then down here is the real useful part, which is combining all of the environment bits, the tag, the level, and the body that I've just created. I'll come back to this in a second. To produce an object which will then be stringified and logged out in a single line. This might not be familiar to many people if you're not familiar with the ES6 syntax. I'm looking over in your direction because it's sort of more on the destructuring side of things. So what this is object spread. So what this is going to say is instead of it being just like put it back as a one property, it's going to look at the object and it's going to spread its properties as if they were defined in the same way as this.
Splicing?
It might be. I think it's just called it's the spread operator. Right. Okay. Yeah.
Removing one layer.
Yeah. It's exactly that. Yeah. And calling it at the bottom there means that if there's anything in there that overrides these, it will override them. Again, it's JavaScript. We have to be careful. But you can get around that by being a bit more obtuse with some of the naming. If someone's logging PID, then I'd be questioning what they were actually doing there anyway. So there's a need for a bit of care, but generally I think you'll get away with it. And then the very last thing that I've got here is this sort of helper function that gets exported, and you'll see this in use in other parts of the app that we'll build, which takes the levels from the top here, and it basically goes through and creates partially applied versions of the logs and sends it back as an object. So you'll get a logger. I appreciate this looks a bit sort of terse, but you'll get a logger object which has a function per level with the tag pre-applied, so that you literally just call that function with your message or your log body, and it will be output. I can show you this in one of the services that we've got coming up later. I think it's in here. Do I have? So yeah, so here I say, this is where I would use it. I call in my package and I call create loggers with the tag of code. So everything that's logged out from this particular file will be tagged the same, so I can tally them up later on. And then when I use this, if I do ever use it, you just call like logger.notice. So that's giving you the level automatically. And then I'm just passing in this object which is saying like, what's the path that someone called on this API and what's the status that they're asking for. And then up here I've got logger.notice, but this could equally be worn. This part, sorry.
Do you have ways, or how do you manage to contain storing inside effect, like the global objects and all this. Is this some discipline that you're applying, that everybody's applying, or how do you do?
How do you do it?
Practically, how do you manage to avoid things making good with global objects everywhere?
So most of the functions that we'll be using will return new versions of the things that are passed in if they change them, which is one way. So it's not relying on reaching out to something that's outside of the scope of the function itself. But it's largely discipline. Yeah. And using things like a library like Crocs or a helper library like Lambda, it helps to reinforce that because they make you work in that way where if you're going to change something, so say if I was going to add a property to an object, I'd use, say, the assoc function, and that will add the property to a new object and then merge in the stuff from the original one. So I'm not changing that original object, I'm getting a new version of it. But it is largely down to discipline and making sure that the libraries and tools that you use are supporting you in that battle. It is quite tricky. It's why people are migrating stuff to Elm and other languages like that. They do that for you in the compile step. I'm going to last thing on this because it's an interesting question. So one of the things that we often come across with engineers working on our production systems is deciding what level you're going to log something at. Now it might sound like a really silly thing, but me putting this particular output on the error branch as a warn is probably the wrong thing, because although it isn't the right, I'm not getting back what I wanted, I'm handling it and it's expected behavior. If my dashboards at work suddenly lit up saying warns have gone from 5 to 100, I'd be getting really concerned about something being broken that we didn't expect to be broken. Whereas this is expected behavior, so I'd probably be logging this as a notice instead. And I'd save error for truly, warns and errors for truly exceptional stuff that really, really shouldn't be happening, that I probably haven't handled properly, or we need to, I don't know, we need to really consider that there's something seriously wrong here. Okay. Did everyone manage to get something up and running then and working and feel happy that they're confident? Yep. Smashing. Okay, so let's move on to the mother of all applications, Hello World. So this is going to be the first part of us looking at this actual architecture pattern. You can see it in the repo that I provided. I've split up my source into packages and services, and the idea is that my core business logic lives in the packages bit and is reusable, and my services is just the mapping between the external interface and those modules. Okay, so in this instance we're using Micro as a library which will provide a HTTP API, and then we're going to call into some functionality that's provided from something else. This is the Hello World app, so we're not going to build a package for that. It's literally just going to return a string. But it's a start in the sort of right direction. So this one is probably just worth really quickly running through together, and then I'm going to suggest we might just have a 5-minute just sort of reset, get a drink, and then we'll start tackling the meat of the actual World Cup application afterwards. So should we just do this one together? Yep. Sure. Okay. So if I go out here and I do JavaScript, has anyone worked with Express before? Yeah. Yeah. So I think Express is kind of like the de facto kind of server software for Node, I guess. This is like just building a single branch of an Express application. So rather than thinking about offering routes, this is just basically offering one route, okay? And you run it in its own process and make the routing happen outside of your application. So it's easier to show than explain, I guess. So if I require in Micro, what that allows us to do is to create an app where Micro wraps a handler that looks very much like an Express handler. So you get a request and a response object, and then you can just return whatever you want. and then it's just the same as you would do in a normal HTTP app. That's it. Now, the micro is provided by Zeit, and they're very keen on the async await syntax in JavaScript, so they would suggest that you write it like this. It doesn't really matter. We're not going to use that async await functionality in our apps, but this will do. It's not listen T either, it's just listen. And hopefully, if I've got this working, and I go to my browser, ta-da. There you go, that is a Hello World microservice in 3 lines of code. So I guess my challenge to you would be maybe do something a little bit more ambitious as a starter and have a think about how it's going to work. Because micro is expecting an async function, that means it will handle promises. So if you were to want to explore doing something to say this was an error, then you can send a rejected promise back, and that will convert it to a 500, which would look something like this, I guess. Let's restart it. There you go. So I got my 500 back because it's returned an error. Yeah, so we'll just quickly work through these bits together, and then we'll take a quick break. Nice. Cool. So just done let's go back to the presentation mode in this, see if it will work. Just to introduce sort of a basic idea of how you might work with some of the standard Node and JavaScript bits and bobs that you can use with micro. Browsers will ask for favicon.ico every time you try and load a page in it, and it's the root. So here we're just adding a rule to say check the path from the URL, and if it looks like favicon.ico, we're just going to send back a 404. So that's just introducing a second sort of component of this micro library. So if you want to just return a value each time, you don't need to use send at all. You can just return it as a value or a promise. It handles that sort of natively. But if you want to do something different, like provide a different status code to your responses, then you're going to look at using something like send. If you get an error, if something's going to throw an error in JavaScript, you can also capture that and use send error, which is, you can get send error in the same way as I've got this at the top there, by destructuring it off micro. And that just expects what you've got there with res and the status code, but then it'll take a third parameter, which is the actual error instance, and that will give you a stack trace in the output that you see in the browser. I don't personally use that because I don't want to show people, I don't want to inadvertently show people the stack trace if an error does happen. I just want it to be like internal server error and just be blank and a bit more secure. But that's it, that's kind of the nuts and bolts of micro. The reason I love it is because it is so simple, and micro is the perfect name for it. I think with things like Express and you get middleware and all the rest of it, there's uses, but this keeps this whole thing very succinct, very simple, very easy to reason about, which is kind of the goal of working in this functional way in the first place, is that you can understand it from the outside. Just on this Hello World app, if you look into the example code that's provided in the services, Hello World actually has a test. So I've structured this slightly differently. So what I've got is the app is exported from one file and then brought in by another, which then starts it up, and you can see I'm sort of pulling the port off the environment as well. But what this allows us to do is to write a test where you can pull that app in, and then you can use this other package, which I've brought in at the top, called test listen. And what that will do is it will enable you in your test, note the slightly ugly async await syntax, but it will allow you to create an endpoint for that specific app, for that specific test, which you can then call using standard fetch library or whatever, and then you can start to write assertions based on the response that you get back. So this is a really contrived example. Obviously, there's quite a lot more to using this, and it's way beyond the scope of what we can do now. But it's interesting to note that you've got tools available to allow you to do more than just unit testing. You can start to write more of an integration test suite with these tools too. And again, because it's just ideally supposed to be just one function that's handling like one thing, it makes these tests quite a lot easier to understand than something that might be the whole of an Express app, for example. Great. How's everyone feeling so far?
Can you just put yours back up for a second?
The Hello World version?
The non-official one that you just wrote.
Yeah. I'm having IDE issues. Who knows what's going on here? It's just terrible. I think basically my work at home are basically saying like this is not a usual usage of this laptop. What's going on? So that's the one, isn't it? So just looking at the test from before, I don't know if anyone sort of clocked it, but having to wrap all of your async stuff with try catch to me feels pretty nasty. But when you're using the async thing from Crocs, that's a lot neater, a lot more declarative, pleasant to work with. And you're kind of seeing the difference between thinking more in the functional programming inspired libraries and the native sort of direction that JavaScript has gone in with async and await. It's very imperative. It's like very do this, do this, do this, do this. Oh, and it could throw at any time, so catch it. Right then. Should we just crack straight on? I was going to say we'll have a break, but I'm just noticing the time, and we're going to be a bit tight on things. So I guess we've got a choice. We've got 40 minutes. Is that right? Yeah, about 40 minutes left. There's sort of 4 things that I wanted to cover off really left. One is writing this more realistic application. One is adding in metrics and looking at how that integrates with tools like tools like Prometheus. And then I wanted to look at circuit breakers, and then finally I wanted to do a bit of chaos testing. We can either build this application together now, or I can talk you through some of the thinking around the metrics and the circuit breaker and leave the building of this application as sort of an exercise for you to do kind of in your spare time. Hopefully the documentation is clear enough that you can do that. Please feel free to shout at me on GitHub if it isn't, and I'll add more. But just to get a general feel, which kind of direction would you prefer to go in? Doing the exercise now or moving straight onto metrics? Metrics? Okay. Just out of interest, did anyone work with something like StatsD or Prometheus before? Very briefly. Do you have Graphite and Grafana dashboards or things like that? Cool. So this would be fairly relevant to you. We use Prometheus at work. We're migrating away from StatsD and Graphite. Primarily because we also want it to integrate with PagerDuty for our alerting, and we're basically removing a thing called OpsView, which is our current sort of single pane of glass into the state of all of our applications, so that our service desk can call people out when they need to, when something's broken. So Prometheus is quite a nice tool. It's got a nice client library for Node that's very, very basic, very simple, which is exactly what you need, because you don't want to be chucking loads and loads of complicated stuff in here. This is purely so that you can have a dashboard in front of you on a big screen on your laptop that says, we're looking like we're healthy, or we're looking like something's going a bit wrong, the response times are spiking, or we're seeing a massive amount of traffic, we need to scale up our stack, whatever. There's quite a lot of detail in this document about why you would want metrics instead of logs. I think I touched on it at the start by saying that basically metrics don't scale with customer traffic, so you can be confident that they're gonna be available at all times. Logs have a tendency of doing nasty things on disks, especially when you're busy. The amount of times that teams in our business have been called out because the disk has run out of space because the logs have just filled it up. That means that if you're not able to log and your application stops working, that's pretty bad. Whereas with metrics, if you start pumping these things out as metrics, you're not going to have that problem. That being said, statsd and Prometheus do work in slightly different ways. Statsd, you push things in, whereas with Prometheus, it's a scrape-based mechanism. So you will provide an endpoint on your application that then will say, that can be used as a place for Prometheus as a system to come and say, right, let's have a look at your application, and then we can add that into our time series database. They provide very, very basic metrics for like counters, which is just incrementing stuff up by 1 or more each time. I tend to just use it as a single digit increment, but it could be like incrementing it by like 10, 50, whatever. It depends what you're monitoring. In this instance, I've chosen request count, so it is only ever going to be 1. A gauge is very similar to a counter, but it allows you to decrement as well. And this is quite useful for things like looking at the number of active queries or number of active requests that you're servicing in your applications. So increment it when you start processing, decrement it when you finish, and you can then plot that over time in a dashboard to see how busy your service actually is. Histograms and summaries are very similar to each other. The histogram just basically plumps stuff into buckets. So you can use it as a way of saying, if I was looking at response times, I would record, like here I've got a thing that starts it and then ends it, and that would then say this request falls into this bucket, and you could start to see the volumes of people falling into different breakdowns. So maybe if we're aiming to respond in 100 milliseconds, you'd have buckets up into 100 and then buckets to 500, 1,000 millis, whatever. And you can see the distribution of the response times across those buckets. Summary is similar, but it works on percentiles. So rather than absolute values, it's just saying like the percentile version of those observed values. I'm not using that in this. On top of that, you can get some default metrics. These allow you to dig into the underlying performance of your system. So how much CPU is being used, how much space is left on your disk, that kind of stuff. And a lot of the times, this is enough. It just pulls out all the defaults for you. You don't need to think about it, and you can just sort of move along. I've got the World Cup fixtures app. I'm just going to start it running up there, running live. And this actually has the metrics endpoint up and running in it as well. So you can sort of see the output Prometheus would be expecting. It isn't really human readable. This one isn't like logs and JSON. This one is specifically for the machines to use. But it looks a little bit like this when it eventually returns. So you can see it's kind of like lots and lots of detail in there. This is all the default stuff. And then right down at the bottom are the things that I've defined in my app. So how many requests has the API had? How many active requests are there? And then this is using summary. So what's the breakdown in terms of processing time for handling a request? If you want to play with this, and you do have time later, if you use the Docker setup in this repo and run Docker Compose, it will spin up this app. It will spin up an instance of Prometheus pre-configured to scrape the metrics from that app, and it will also spin up a Hystrix, so you can start to look at the various aspects of what we're building here. Okay, so having not built the app, it will be a bit more tricky, but you might want to do this in that Hello World app. It'll be pretty noddy. You're not going to be responding with too much interest there, but essentially using the Prom client that is part of this repo, we're going to look at adding a counter, and we're going to look at adding a gauge and potentially a histogram as well, although it won't report much useful because it's actually doing no work to take any time. So yeah, do you want to have a go at adding that yourselves to the Hello World app you've built, and then we'll look at how it's been added to that World Cup fixtures app that I wrote as part of the sort of example code. I'll bring up, these examples will work. I'll also just put up on screen how I've instantiated stuff up here. There we go. So that gets you, this line here at the top gets you, if I can show you, that line. That gets you the Prometheus client package, and then the metrics are defined below. And I'll sort of leave it up to you to then implement that as part of the processing body of the microservice. How's it going?
It's going alright. Honestly, I'm mostly reading through and getting familiar with the libraries because of my junky laptop.
Okay. How you doing?
File was that?
That is the get. If you go into services and it's in get fixtures and get fixtures.js.
Modify this.
You're gonna nab that, yeah. Well, but what I want to do is to sort of put these into your hello world that you were writing, and so like here. So if
This.
yeah, that's it. So if you look at the app down here, I'll go through it afterwards to sort of explain how it would work in a more realistic environment. But essentially, like you've got your handler, and all of this to here is just kind of stuff that's related to the HTTP request and the metrics, and then at the very bottom, this is calling the flow that's the actual application logic. So they're separate. So the idea is that you have this thing that is just a function, essentially, that provides you with the business logic, and you're decorating it with all of this other stuff. So this can be pulled out and tested, which I think there should be some tests around that. And then all this other stuff is just like how we're decorating it with extra information so that we can actually run this properly in a production environment. How do I
output the metrics?
output them? That's a very good question.
That's what you're supposed to do, right?
Well, no, I just wanted you to instrument your code with it, but
Okay.
yeah.
The endpoint.
I think, is that on the document as well? Let's have a look. No, I haven't put it in. I thought I had. I'll give you a sneak peek. That's how you would turn it into something useful to actually look at in a browser. Yep. How's everyone doing over this side?
Actually, yep, that's right. I'm just navigating my way around the different files to steal things off and put
Yeah.
some instructions everywhere.
Cool, yeah,
Yeah.
good. All good over here? Amazing. At the moment, it's everyone just running node and then file name. Yeah. Okay.
You're using or are you using other framework for the
We use micro.
very bare bones?
Yeah, that's it.
I can imagine that most of the time you only want 1 or 2 routes in every application.
Yeah. What we're trying to do is kind of emulate the ideas that have sort of come forward more recently with functions as a service, especially things like AWS Lambda, where each endpoint in an API is rooted to its own sort of stack, and micro fits really well in that world. We're not particularly, we can use Lambda at work, but AWS isn't necessarily like a first choice for us because a lot of our services have to be hosted in our own data center, which runs just off the south coast of England. So we tend to have a lot of virtual machines and a lot of hardware that we run stuff on, and we're moving towards using Kubernetes, which this sort of stuff actually fits quite nicely with because you can define a pod per micro instance, and you can spin them up and scale them independently and whatever. If anyone's familiar with the concept of bulk heading, this kind of works really nicely in that regard. So if you're running each of these apps in their own process, they're not, one endpoint can get hot and maybe go down, but it won't affect the rest of your app. Whereas if you're using something like Express and you had one particular route that got hot, that could potentially impact the rest of your app as well. So we're really isolating potential failure into just one area. And again, it comes down to this idea of building a very small single purpose thing that can then be composed with other things at different levels in the stack, whether that be at a service level or at a function level or whatever. Yeah. It has some, it's not like perfect, but I quite like it as a way of building things. Perfect?
It's types.
Yeah. Wait, yeah, it'd be nice with types, wouldn't it? Yeah. One day. Has everyone managed to see metrics being reported out to a metrics endpoint for your Hello World app? Okay. Right, so I'm just going to jump back one bit and talk about process management because it's quite apt really, and it sort of leads into what we were just talking about. The 12-factor app describes running an app as one or more stateless processes, and if you've ever worked with Heroku as a platform, who are kind of the sort of originators of this idea of 12-factor apps, this will make a lot of sense to see how their platform works. You have this concept of dynos and you spin them up and down, and they're just basically stateless containers. What I've tried to set up here is a way that you can emulate working in a way where you have multiple processes running at once to represent different microservices, but then you can also scale each of those processes horizontally to sort of replicate what it might be like in a live environment. So to make a completely contrived example, your Hello World app, you might want to be able to run that locally with 4 processes to take the most advantage of your CPU, but also to make sure that there's no inherent state being required between requests to your service, because in a load balanced world where you've scaled up your application, there's no guarantee really that you're going to always be hitting exactly the same instance of the same application each time. So being stateless is really important. To do that, I'm using a tool called PM2. It's a process manager which allows you to define how many processes you want running at one time. There's various other parameters around whether you want your files to be watched so that they will restart on changes. And you can define what type of clustering mode you want, whether it's going to fork processes or use the native node cluster under the hood. And then on top of that, it gives you some really nice capabilities for monitoring the status of things. I'm actually using it locally as part of this workshop. If you look in the sort of root of the repo, there's a services.config.js, and what that does is it basically declares all the apps that I want to run. I want PM2 to run, and how many instances of them I want to run. So at the moment they're all just running one instance, but it's really, it's kind of like a way of describing my overall architecture in one file, which is quite nice. I don't use this in production because we tend to build each service into its own Docker container and run that in its own way. And you can, if you're interested in exploring that, I'm not going to do it now, you can see how you might build that out into a service using the Docker Compose format. Down here is where I run all that stuff, and at the moment actually I'm just running it in one container, but it would be very straightforward to run a container per service because you're building Docker images per service. Little aside there. So PM2 is really nice. This is what you see when you get a status, so it tells you how many apps you've got running, how many instances of those apps you've got running, how many times they've restarted. You can see this is when I was working on this workshop, so it was restarting quite frequently, so about 100. What's the uptime, how much CPU and memory each one's using, whether you're watching files to restart on change, etc. But then you can also have a real-time version of that by running PM2 monit. So I'm going to hopefully be able to show you this. If I can get this onto the screen. So if I go to the workshop and I say PM2 start services.config.js, that'll spawn a new PM2 instance. It'll use my config file and it'll spin everything up. They're all in watch mode, and then if I call PM2 monit, I get a real-time updating dashboard of everything that's going on. If I go to my endpoint, there we go. I can also see my logs. So you can just get all the stuff that's coming out there. I don't think I'm logging anything on that one. That one might not be working. Yeah, so it's really nice. It's a way to sort of emulate what your applications might look like in live, locally, and it's a pretty decent tool.
Don't you run the risk of duplicating things like having one set of configuration and for the one set for the production, then have one drifting from the other, that you kind of lying to yourself because basically you are using a tool which is not a tool you use in production.
Well, actually, that's interesting because I do use it in production. So the way that you can run, let's go in, I'm going to just show in here. So when you define your Docker images, so say I've got one for the World Cup fixtures package that I've shown you. I'm actually using the PM2 runtime. Yeah, so you can reuse your services declaration file there and specify an environment, or you can just use PM2 as the runtime anyway. But the main thing about the difference between different environments is it should be the configuration you pass in through things like environment variables. And so if it's missing, it won't work. Your code remains the same. And I kind of get where you're coming from, because I grapple with this a lot. Like, am I duplicating loads of work by having a version of this configuration file for dev, a version for live, or whatever? But I've only found with this, especially when I was trying to make this really straightforward to sort of convey it in the workshop, I've only really needed this services config for the local environment, and then running it in Docker, it just kind of works as it is. If I show you this, going way off track, because I've been running these applications as Docker images on the Now platform, which is a container platform provided by Zeit, you can specify your configuration in this JSON file here. So you are having to provide configuration per environment. But the nice thing about this, I don't know if you can see it, is that you can embed secrets into your I guess, your account for Now. So I'm saying here, I'm going to need an API token, but I'm not going to provide it here because I don't want to commit secrets to my repo. I want you to look into the Now platform and get me out the football API token that you should use, and then pass it in. And so I'm kind of using PM2 to manage my processes. I'm passing my environment in through environment variables, and then everything's kind of running the same code in every environment, just configured differently. There's quite a lot of information about configuration in here that we're not going to go into because we just won't have time, unfortunately. Yeah, which is a real shame actually, because there's some some quite complicated stuff in there that's quite interesting to look at. But in the name of like making a live application, I think we should focus on some of the other bits. So for the last section, before we kind of open it up, just go on any questions that people might have, I want to talk about circuit breakers. Because this, in this, you can see now, sort of giving you the application pattern that we've got, why circuit breakers become important, because you're running all of these things as independent processes. They're going to be running on their own endpoints and talking to each other over HTTP probably. So if one of them fails, you need to be able to protect against that failure. The circuit breaker pattern's a popular one. There's a really good implementation of the circuit breaker pattern from Netflix called Hystrix, which the client library that we're using here is based on. And what that provides you with, as well as a really solid implementation of a circuit breaker, is a way for you to look into the state of your circuit breaker and say, is this thing functioning as expected? There's a lot goes into making a circuit breaker. It isn't just a case of looking at errors and saying, stop doing stuff. Realistically, there's all sorts of different reasons why something would fail. So a timeout might want to have a different action to handle it, to just a general like instant network failure, or the application's just not responding at all, or whatever. You need to think about this in terms of what they mean and how you want to handle them, but also whether they actually imply long-term failure of the end service or not. So rather than looking at total numbers of errors or failures, it looks at bug density or failure density over time, and you can configure that. So you can say, if the threshold in a certain window reaches more than 50% of my requests are failing, then I'm going to open my circuit breaker. I'm not going to allow any requests to go through. And then you can have a cooldown period where nothing goes through, and then it might start to let what they call the half-open state come in, where maybe 1 or 2 requests go through to see if the other service is healthy again. If you get a good response back, then it would indicate that it is healthy and the circuit breaker closes to allow your service to talk to it properly. If it comes back as an error, it will stay open and further requests won't go through. Probably easiest to show by looking at the dashboard. So this is the sort of output that you can get using the Hystrix dashboard provided by Netflix. This is something you would have to run yourself. So it's not like a Node thing. This is a Java application. I'll start up with Docker Compose in a minute. You can just see the difference in the amount of output that Spring kicks out starting this up. It's quite phenomenal. But essentially what you get here is a way to say, I've got a circuit breaker wrapping this call to a third party's API. What's going on? What's going on right now? So you've got a blue line is indicating the level of requests going through, and the circle is also kind of a thing that indicates the busyness of this circuit breaker. The green numbers are showing the number that have worked, the amber ones are the ones that have failed, and the 38% is giving you a rough kind of what's the error rate that I'm looking at right now. The amber, let me get this right, I think the amber is showing that these requests timed out, so they weren't hard failures. They didn't meet the timeout requirement that I set for this call, whereas red would be this just failed, this just broke, it's not working. And then underneath that 20, you can see the blue 0. What that is saying is how many requests the circuit breaker didn't let through because the circuit was open, or because it wasn't gonna let you talk to this remote service, this backing service. Is that okay? Good, reasonably clear as to why we'd use the circuit breaker. Now, the thing about this, again, going back to the sort of the functional programming aspects of this workshop, this is an inherently stateful thing. You can't have a new circuit breaker for each new call because it just wouldn't work, because it needs to know the status of all the calls. And again, it's why I would probably advocate using a library rather than trying to write your own, because you don't want to be opening up the can of worms that is managing global state for something like this. Let this well-tested thing that's already out in the open source world, that's used by thousands of people, be battle hardened for you, and then you can rely on that. Wrapping, the exercise is to wrap the original HTTP client that you have with a circuit breaker, and see how that can be messed with by sending it to different endpoints or whatever, or turning off the ability to talk to a third party through Toxie proxy or Charles proxy or whatever you're going to use. to see what happens when in the event of failure. I don't think we're going to have time to go through that, so I'm going to just walk through how it's set up in the code examples that come as part of the workshop, and then if there is sort of more that you want to dive into, we could probably have a play with it. So if I go into the HTTP client breaker, you bring in breaks. This is the overall library, and this is where all of the beautiful global state is managed. And then what I'm going to do is I'm going to slightly tweak the way that we're wrapping the call to the fetch API. So if you remember, that's a promise-based API. So we need to handle then providing the success path and catch providing the failure path. But we can't do it quite as neatly as we were doing before, because we need to also wrap it with this breaker thing. So here I've got a create breaker function, and this is going to take a name and some options. Now here's some defaults that I'm going to set up. I'm going to basically say that I don't want any request I make, I don't want to take longer than a second, because if I do, I risk my application slowing down too much and being a strain on other applications and having cascading failure across my whole architecture. I'm just passing in some stuff to like help speed it up a bit, because it doesn't need to try and work out if it's a callback style or a promise style function. It is just a promise style function. This is using that sock function I mentioned at the start. This is creating a new version of these defaults with names set to a name that is passed in, which you can just see here. This is the function call. And then what I'm doing is I'm saying, right, I want to create a new circuit breaker, wrapping this promise returning function, passing in my defaults and these options that are supplied here. So this has now created a new object that we can use to call the underlying command, but with a circuit breaker wrapping around it. So the mfetch function from before, which was just made by async.fromPromise, we're going to have to do a little bit more heavy lifting to make it work now. So what we're going to do is create a function that takes URL and options, which is the standard fetch API, and we're going to return an async where the internals of the async are passing those options to the circuit breaker. So this fetch breaker.exec, that essentially calls the underlying fetch function that we wrapped. And then based on the status of the circuit, the timeouts, all the other stuff that we've set up, whether we've provided the fallback function, there's loads you can do here. It will either return a successful response in the then branch or a failure in the catch branch. And again, similar to when we were passing the JSON in the very first exercise, this is basically just converting that promise-based API to the async task, the async monad that we've got and we want to work with. The last little bit here is just, again, similar to the original one. That will just return me the standard response object with the dot status property and the JSON function. 90% of the time, I think I'm going to be wanting to get the JSON out of this response, because it's going to be an HTTP call to another service. So I'm going to provide this shorthand version, which is mfetch JSON, which is just the composition of the original fetch and then the parse JSON function that we previously wrote, which is just up here. And that's it. So that then becomes, the API there just becomes a drop-in replacement for the one you were using before. So if I jump over to the get fixtures service the bit that actually gets the data from a third party, I've got it actually wrapped in here. I think, no, there. Here you see I'm just setting up the breaker as before, because I did this before I went through the example to create a new HTTP client version. So this is using the same sort of principles, and then this is the program flow. And as you can see, it just looks, for all intents and purposes, exactly the same as calling the fetch that you wrote before. It's just this time you've got the guarantee of a circuit breaker wrapping it to handle any of those failures that you don't want, or to make sure that you're not going to go over your response time SLA, You're not going to be hammering a downstream service that's struggling, etc., etc. Right, and while that's going on, I'm going to just spin up everything in Docker, because then we can have a play with it all in sort of one place. How does everyone feel about that circuit breaker implementation? Does that make sense? Is there anything that's kind of a bit kind of odd about it?
Do you, off the top of your head, if that same library allows you to have other backup strategies, like how flexible are the breaks?
I'm not sure about back-off strategies.
Or, you know, other recoveries, other things that are similar to circuit breakers.
Yeah, no, it's purely just for the circuit breaker side of it. There's some interesting things you can do with it with a fallback, but what I found is by modeling it this way, by sort of embedding it in the heart of that async, you can put your kind of failure strategies and the recovery into the standard program flow, rather than having to handle it in the circuit breaker itself, which is quite nice. How are we doing with Docker Compose?
Maybe we provided, I didn't see where you are, where you manage when the circuit is open. What's the, how do you say what to do when the circuit is open?
It just so in that instance, it just comes down the error branch of the async. So it's a rejected promise, and it will give you.
But it's rejected by the circuit breaker.
Yeah. Yeah. So with the circuit breaker wrapping it, you can basically get failures from getting the wrong sort of response codes, a network failure, the circuit being open, or a timeout, amongst other things. Encountered errors. Oh no, what have I broken?
PM2 is a node-only project, right?
Yes, but one of the nice things about PM2 is that it's kind of agnostic of what it wants to run. So you can run you could run like a Python app or something with it. It's a bit like a
Like a script that's relatively straightforward and has like a bin-in shebang.
Yeah, exactly. It's kind of a replacement for supervisor D.
Gotcha.
It's just it's a bit nicer to work with.
Yeah, it looks
The clustering works nicer because
more pleasant and obvious.
yeah. I don't think it's. Well, I've definitely broken this somehow. Error starting bound for port 3000 is already allocated.
Do you run PM2 dev inside?
Do I?
Do you run PM2 dev inside?
Yep.
I never got that.
Oh, right. Okay. Well, I can sort of, while this is loading up, I can show you how I've got that working. The thing I found with the PM2 dev is that it needs the volume setting up correctly. So with the app here, the Docker file will copy all of the code into the container, and then in Compose at the bottom here, what I'm doing is saying, overwrite what I've copied in with these files, so that PM2 dev is basically just looking at the host file system rather than the internal container one. And so when something changes, PM2 dev will pick that up and it will restart. It's quite nice if you don't want to have Node running, or you want to run different versions of Node for different apps.
Or if you just plug it.
Yeah.
You need to restart.
Yeah. There we go. Well, you didn't get to see Spring fly past with all of the millions and millions of lines of logging. So this is everything running inside of a container now. Great. And you can see this is the sort of response that you might see if you get a timeout from your circuit breaker. Luckily, this API that we're hitting is based in Germany, so 1 second is quite a good indicator of whether something's up and running or not. Like it's just about going to make it most of the time. With this compose file started, you can go to the Hystrix instance, and you can plumb in a link to the API, and I think it will be 8001 histrix.stream, and you can monitor the status of your circuit breaker. So if I hit that, you can see how this changes over time. So 1 failed, 5 have passed, and it's just constantly ticking through, updating with the status of my circuit breaker. Like I said before, Prometheus is running in here too, so you can go and play with looking at time series graphs of what's happening in your apps. This is more fun to play with because you've also got at your disposal Toxi Proxy. I'll just make that a bit bigger. So what Toxi Proxy does, in a nutshell, it allows you to simulate failure locally, which is really handy for stuff like this. So you can set up an API to be proxied through. So essentially what you've got here is my fixtures API is going to be talking to Toxi Proxy's container on port 9000, and all that's doing is mapping it over to the API that I actually want to call. And then to have a bit of fun with it, you can start to inject failure, and I think I've got that in here. So if we consistently add, I just need to change the name of that to football API proxy. So now all of my requests to this will time out. And you can see that here, that the error ratio is 100%. And just to really belt and braces prove that this is working, I can really hammer it with Siege or something, and now you can see that my circuit breaker is handling all of those failures. It's not letting anything through because it's clearly never going to succeed because the remote service is too slow, it's failing. And the blue number at the bottom, 929, is showing that it's basically caught all of those requests before they even try to be made. So just a bit of fun.
So the Toxi Proxy, does that like allow normal HTTP requests to go through, and then
Yep.
you can like basically stuff and see how they act?
Yeah, they have a suite of what they call toxics, so you can introduce latency or jitter, or you could make things like randomly fail or take too long, or whatever. So it's quite nice for being able to simulate failure modes.
Does it work only for HTTP?
I don't know actually. I think it probably handles.
I think it does TCP.
I think it does TCP.
TCP?
Yeah,
Oh, cool.
yeah. It's from Shopify.
Yeah, like MySQL and Redis protocol.
Yeah, you can wrap most things. Yeah. Okay, cool. I think we're pretty much out of time, but if there's anything, there was loads of content that I didn't get a chance to cover, so if there's anything that you do want me to go over, I'm more than willing to stay around for a bit longer and chat through with you.